We're going to be taking a look at a couple of examples in this video, these two right here, and then I'll have a video on one more example. No spoilers, but that one might take a little bit longer. And we're going to just see which of these two examples is worth looking through, and we're going to see which one of them may or may not be the most simple. Side-side angle problems for law of sines, the ambiguous case, have some problems where you'll just have no triangles to work with. It may be that the set of values doesn't actually satisfy the conditions of making a triangle. As far as the other nice type, you could have a right triangle. And if you had a right triangle, you would see that there's a single triangle as a solution for sure. And then if you're really lucky on the special cases, where you could have two triangles, you may still end up with just one. And so we're hoping these two examples here fall into one of those nicer categories I just mentioned. Let's just go ahead and start with the first one. All of these are going to be set up the same sort of way. And if you watched the last video, you should already have the basic premise of this. And if you understand law of sines from previous videos, at least the basic layout, then the form I'm going to show you now should not be too surprising. I know that sine of big B, notice that's the matching pair I don't have, is big B with little b, would have to be equal to little b times sine of big A all over little a. That should be kind of clear from our basic law of sines formula, because if I divide this b back down here, we see that traditional pattern. What we said in the last video, though, is we can use this to test and see whether or not we have a certain number of triangles. So I'm going to input all of my values that I have here, and we're going to go ahead and put an approximate. You know this is most likely to be a decimal. Let's go and grab the calculator. I almost dropped it. We have 29 sine of 31 all divided by 9, and we see about 1.66. And if you weren't sure if that was correct, do double check your mode for whatever calculator you're using. Do make sure you're in degree mode. I usually put that on there on my own, but it defaults to radians. We see about 1.66. And it's important to note here then that if sine of b is equal to 1.66, this means that sine of b is greater than 1. If you recognize that as one of our conditions to watch out for, we now know that there's no possible triangle for this particular problem. There are no triangles that will have the length of 9 and 29 for sides, with that opposite angle of the 9 being a 31 degrees. It is not physically possible for that to happen. I have to apologize, I'm a little bit stuffy. So for this one, we're taking a look here, and we're seeing a very similar layout. We have two sides here, and we have a matching pair for our b's. So we're going to take a look at C. We're going to evaluate sine of C. So in a similar fashion, we'll write down its corresponding side, and then we'll have sine of big B all over little b. I'm going to evaluate that, and we're going to find out what's actually happening here. So let's see. We have 5 sine 32 all over 17. Okay, this is giving me about 0.16. We'll say approximately 0.16. This is good news. This is between 0 and 1. We know that that means we could have two triangles. That's the downside here. We could have two triangles to work with. But we at least know that we're in a situation now where we can actually work with triangles. We don't have this weird situation that happens up here. Now the fact that this is not equal to 1 means that we don't have a right triangle, which is unfortunate because those are guaranteed to be a single triangle. But what we're going to do is go ahead and evaluate sine of C. And I'm going to do this very carefully. So my calculator, I had come up with this already. So what I want to do is take inverse sine of that exact answer to get as close as I can to a value. And I'm looking at about 9 degrees here. So we're going to say approximately 9 degrees. And what I'm going to do in my problems is I'm going to denote the other possible angle. The other possible angle for this triangle is going to be this thing called C prime. And I'm going to call this a little sidebar, a little side note. C prime is the supplementary angle to our regular C. So I'm going to subtract the 9 degrees from C prime. We find out that C prime is going to be, oh, you know, over here, I just saw what I wrote down. I have to apologize for that. This would be the angle C is approximately 9 degrees, not the sine of C. So the measure of angle C prime is going to be 180 minus 9, which is 171. And so I go, okay, well, that is a possible alternate angle. So this is a possible angle. And I can test this very easily. I'm going to go ahead and kind of scribble this over here. 171, first of all, it's massive. It is possible for that to be an angle in a triangle, but it's pretty large, so I tend to suspect it may not be. I know that if C prime is a possible angle, then it must add up to A prime and my original angle B that I was given in a way that they add up to 180 degrees. But notice if I take my original angle of 32 degrees and I add it to 171, so if I take B plus C prime, this is 32 plus 171, and that's a lot. That's 203 degrees. It is not possible for two angles in a triangle to add up to over 180 degrees. This right here tells me, this right here, I'll just make a note here, since this is greater than or equal to 180 degrees, C prime is not useful. And that's really the check here. If this angle had been less than 180 degrees, that means we would have room for a third angle. It would be possible to have an A prime to go with C prime. This right here tells me then that we only have one triangle to work with. So I'll just say we only have one triangle. So now that we've done that, now that we've acknowledged that, we're in great shape. We are going to rewrite some information just so we have it all in one spot. So the measure of angle B was 32. We just found the measure of angle C is 9 degrees. We know that little b is 17. We know that little c is 5. So these three were given to us. We found the 9. So to find the measure of angle A, we're going to have a very nice time of this. We just take 180 minus 32 minus 9. So remember that they all add up to 180, so subtracting those two gives me the third one. So the measure of angle A must be 139 degrees. And at this point, I would go ahead and make sure to use my original given information, the little b and the big B. But I can find little a very easily using the same sort of setup I used earlier. Little a is going to be b sine of big A all over sine of big B. So to find little a, I'm just going to input these values and then we'll be done with this problem. So sine of big A was 139. Sine of big B, which was 32. And this is just a matter of plugging in. So just bear with me on this last part. We'll get this value here. Hopefully that helped you kind of see what's going on here. I know there's a lot of snuffling happening in this video because of my allergies, but hopefully that wasn't too distracting. I'm going to go ahead and say that just because my other things are all rounded to whole numbers, that we'll just go with a nice 21 here for the side length of A. So as a quick recap, in general for these problems, you're going to run through finding sine of that angle. You're going to test those values you get. In this case, because I was between 0 and 1, I knew that I might have two triangles. I went ahead and found the angle that I know will work. This one will always be an angle that we can work with. It'll always give me something for my triangle. Over here, though, we come up with a supplementary angle to this guy, and I called it C prime. We said that that supplementary angle could give me an obtuse triangle that might work as well. But we saw that our angle was much too large. When I added it back to my original angle B, I got a value way too large for my triangle. If this value ends up being greater than or equal to 180 degrees, you don't want to use C prime. That meant we only had one triangle, so we finished this out using basic law of sines stuff to kind of close it out. For triangles where this actually ends up working out here, where this is less than 180 degrees, the only difference with those problems is going to be that you can just go ahead and do essentially another problem. You just use C prime instead of C.